Hi guys, welcome back to my channel. My name is Radhika and today we are going to solve house robber problem 3. I know this is too much of a house robber, but believe me, this is different from the last two problems that we solved. Obviously, this is an extension of that problem, but the structure is totally different. So let's get into the video. The problem is that the thief has found himself in a new place for his thievery again. There is only one entrance to this area called the root. Besides the root, each house has one and only one parent house. After the thief realized that all the houses in this place forms a binary tree. It will automatically contact the police if two directly linked houses were broken into on the same night. That means, and they determine the maximum amount that the thief can rob without alerting the police. Yeah. So the problem is that this time the houses are arranged in a binary tree, and the constraint here is we are not allowed to rob the houses which are directly linked, right? So if we have robbed 4, suppose, we cannot rob 1 or we cannot rob 3. Or if we have robbed 3, we cannot rob 4 and 5, and we can rob 1, 3 and 1. Okay, so we have to find out the maximum amount that he can make while robbing. So what approach can we use here is we will use recursion. So what I'm thinking is, what we'll do, we have two options: either we rob the root or we do not rob the root. So if we rob a root, like if we think of only this, if only our tree is suppose only this 3, 4 and 5, so if we choose to rob 3, then we can't rob 4 and 5. So what we have to do is we have to choose from either robbing the root or not robbing the root, the maximum of that. So if we rob the root, then we get 3, and if we do not rob the root, then we can rob left and right. So 4 plus 5, which is 9, so maximum of 9 and 3, which gives me 9. So we will rob 4 and 5 and not rob root, right? So this is the logic that we are going to use. So we have to obviously write another function that will recur. So we only pass root. Fine. So this returns me an integer value that will be the maximum value that can be robbed, and it takes a parameter which is the root of the tree. Okay, so first of all, the base condition, if root is equal to null, that means we have reached the end somewhere. So we return 0 because that will not be added anyway. Sorry, return 0. Okay, now, so as I was saying, so we return maximum of either we rob the root or we do not rob the root. So what we do, root value, right, plus, now this is going to get a little complicated, so please pay attention. What we are going to do is the left of root and the right of root can be present or cannot be present, so we have to take care of that. So how do we do that? We check if root, we are using ternary operator here, if root of left is present, then we take that into consideration. So what we do is we rob util root left of left. Now, why is this? Let's say we are taking this tree and we have chosen to rob 3. So that means we cannot rob 4 and 5, but after 4, like 1, 3 and 1, we can rob. So if you see, it is a recurring problem for one tree rooted with 1 and for tree rooted with 3. It's the same problem, right? The same thing we can repeat. So that's why rob util, we are calling the same function with value root left of left. That means we have robbed this, we cannot rob this, now we can rob this one, right? This plus we can rob the right of it, right? So rob left, sorry, and left's right, right? Now pay attention, this is the ternary operator that we were using. So if roots left is there, if it's not null, then we do this or we take 0. Like in this case, there is no left of this, right? So we add 0. yeah, so we have added root value, we have added roots left, and what is left, we have to add roots रूट राइट मतलब अगर मैंने 3 ऐड कर लिया है, सो मैंने 4 को छोड़ के 1 3 ऐड कर लिया, नाउ मुझे 5 को छोड़ के इसे ऐड करना है. So we just put a plus sign plus. अच्छा, let me line this in another line so that it's more clear. Okay, इसको भी अलग line में लिखते हैं. Cool. Now, if root same will repeat the same step. If root right is present, then we rob root right left, and we rob root right. Oh, I have written here rob. Okay, otherwise we add 0 because we have to add something, right? Otherwise it will throw an error. So yeah, so this is what maximum of either this comma. If we are choosing not to rob root, then it's very simple. We have to just we have to rob the root left plus rob root right. Simple. Okay, let me see, just check it once. Correct. Right, okay. Let's just run this code and see. Let's just put this in bracket. Maybe that's what they want. Putting this in bracket. Let's just submit it now. As expected, our time limit is getting exceeded. That is fine. There is no problem with the logic. Only our time is getting exceeded. So we need to do something. Now, the next step, like if you are doing it with recursion, you want to optimize it, what you can do is use memoization. So how we can do that? We just need to store whatever result we have got and use it later if we want to use it again, right? Instead of recalculating. So यहाँ पे हम वही करेंगे, हम इसको मेमोइज कर लेंगे. तो हम मेमोइजेशन के लिए सबसे पहले हमें कुछ एक डेटा स्ट्रक्चर चाहिए, विच इज अनऑर्डर्ड मैप ट्री नोड, and दूसरा value होगा integer because we will be storing it as a pair of tree node and the integer, like the maximum you can drop if you are at that node, right? DP from that node it will be stored. Now we'll just use it. Now if there is like if whatever wherever we are, right, if that is already calculated, so that from that root if it's already calculated, it's not equal to dp dot end. That means we have already filled this, right? Then we return dp of root, right? Otherwise what we do is we save this. Dp of root is equal to max of this, sorry, and we return dp of root. Simple. Let me check. Yeah, it's fine. Looks good. Let's just submit. Confidence. Not run it. We have directly submitted. Okay, so it's getting accepted क्योंकि अब हमने अपना जो है optimize कर दिया है इसको. So now it's getting accepted. So that's it for this video. I hope you enjoyed it. Now this is the end of house rubber problem. From the next video we'll do some other problems. Do suggest me in the comment section below what problems do you want me to pick. I will be back with another video very soon. Till then, bye bye. Happy coding.